Okay. We need to use sided limit, one-sided limit in the case we have absolute value, because even though we have absolute value, it's one function, but because it leads to piecewise functions. So as a result, when we consider one-sided limit, we have to look from left and right. The rules are different. In particular, I like to start with the understanding of this function we call absolute value. It's very, very important that you fully understand it. Okay, so let me talk about where it came from. It came from very simple observation. Okay, the absolute value of a positive number is the same as the number, right? You can substitute 2 by any positive number. They're always the same. The absolute value of 0 is 0. So in these two cases, right, so what do we notice? That if the number in consideration is greater than or equal to 0, we call it non-negative. The absolute value of it is going to be the same. Now, third case, if absolute value of a negative number, say -3, and the answer is going to be 3. Of course, everybody knows that. And 3, if you substitute by -4, you're going to have 4. You're going to have 4, right? 4 is the opposite of -3. So how do we express that in mathematics? Well, 4 is negative of -4, right? So if this were x, x is negative, and this is x. Does that make sense? I hope that makes sense. So if x is negative, okay, so if x is negative, the absolute value of x is going to be its opposite. That's where it came from. Okay, so I need to remove this because I don't want to cause any confusion. I still use the example to put it here as say -3 is 3. So it is based on the simple observation that we have the following piecewise function for absolute value of x, right? So these two sentences, I often write it down as, I want to put it into words. I want to put the words in your mind so you understand the meaning. Okay, so here's the narrative. Okay, I want you to reflect on these examples. If you still have a hard time understanding this, is that the absolute value of a non-negative number is the same as the number. Okay, and the absolute value, which is for the second part, is the absolute value of a negative number is its opposite. That's it. So these two sentences really just express these two observations that we've been so familiar mathematically. So bring these two sentences together, and mathematicians made it into some shorthand notation. Okay, mathematicians made it into some shorthand notation. Okay, so what are these shorthand notations? Shorthand notation goes like this with switch order. Okay, so here to make the shorthand notation, we switch order. We bring this over to the back. Okay, and we bring this over to the other side. This is a change of sentence structure. Okay, and next, right? absolute value of x, absolute value of x repeats, right? So we're going to make it into one, the absolute value of x. So make it into two branches, okay? Two branches there, right? So the if statement is in place, right? And the other if statement is in place if x is less than 0. Do you see that? Do you see that? It's just a shorthand notation. If the absolute value of, the absolute value of a non-negative number is the same as a number, the absolute value of negative number is its opposite. That's it. Graphically, that's the curve. Okay, so I'm going to put it up here. Okay, so that's the graph. You guys learned it before, so review it this time. Hopefully, this is the function no calculus class can get around without doing it. So you just have to do it. The domain is all real numbers. If we're interested in if any point of interest of a limit, right? If a is not a 0, no problem. Direct substitution, right? For example, if I say, I'm going to consider this limit, right? A is 2. No problem. We can do direct substitution. The direct substitution will lead us to the absolute value of 2, and that equals to 2. No problem. But the question happens when we consider limit when x approaching 0, right? So in that case, right? So if we can bring the picture over to for our convenience, right? Then this is a slightly different rule approaching, and you also use this piece, right? We just talk about how to use piecewise function, right? We just use piecewise function. So you can just look at this rule when x approaching 0. So you look at when x is approaching 0 from smaller than 0. And the other one is x approaching 0 from larger than 0. There, right? And you get to use these two branches. When x approaching 0 from smaller than 0, that means x is less than 0. So you're going to apply this rule, right? So this is going to be negative x. And direct substitution, of course, you get 0. And in the other one is, you can also do direct substitution anyway, right? But if you from the branching, and this is x approaching 0 from larger than 0. And that's the same, x is larger than 0 as x approaching 0 from larger than 0. So we use this rule, and that's x, and direct substitution, you get 0. Or you can just directly substitute by 0, no problem. However, these functions get to be tweaked, right? We tweaked it in so many different ways, right? Divided by x. You're going to see this function again, or similar function again, right? When we consider this function, the basics is always this piece, what absolute value. And we also think of it, okay, this is the basic, it's divided by x. So the domain for this function now is x 0. X cannot be 0. So for each tweak, you might come up with some kind of new situation with a new domain. Okay, and how this, right? So when we have absolute value of x divided by x, right? The top has 2 branches, so you're gonna have 2 branches. You're gonna have 2 branches. There we go, right? And you basically take this piece and copy right here, right? The absolute value of x divided by x. So this piece divided by x. So x divided by x. And the next piece, right? It's negative x divided by x. Divided by x. And that's how we get the function at the beginning. Wait, did I put it there? Yeah, that's how we get the next one. We get the next one. X divided by x is 1. Negative x divided by x is negative 1. And this is one tweak. And there are many, many other tweaks. Right? So this is the graph. Right? This is the graph. 0 is undefined. So we have 2 circles there. Right? Limit interest. Well, limit interest, if a is not 0, you just direct substitute. If a is 0, the limit does not exist, because limit from the left and the limit from the right are not the same, right? Okay, so these are the cases because we have, so let me just complete that narrative. Okay, I'm sure you get it, but since I'm talking about this, it's better make it complete. Wait, okay, copy, right? So this limit does not exist. Exist because gee, I better remember where I find that because symbol. Here. There. Better remember binary relationship. Okay. Because this limit, right, from smaller than 0, they both exist, not the same. Okay, so these two are not the same. So larger than 0, right? They're not the same, because this piece equals to -1 and this piece equals to +1. Okay, so that was pretty straightforward. That's pretty straightforward. Number 29, I think I'm going to leave that for you. Okay, at 4, it's undefined. It's undefined, right? So there are numerous other absolute value situation, because on this piece, I mainly want to talk about absolute value situation. Then we have seen a couple examples, right? Sometimes when absolute value limit are involved, and sometimes limit exists, sometimes limit does not exist. In this case, you just have to deal with it individually on case-by-case basis. Okay, in this case, we covered in class, and we have these 2 pieces, right? And the limit, point of interest, right? Other places you just direct substitute. Wait, I'm sorry. Here, no, right there. Okay, 2 pieces. 2 pieces. Okay, so we work with that. The way we work it is very similar. You just operate on it. And here's a graph. The point of interest is 3, but it looks like when we're approaching 3 from left and right, they're the same. They're the same, right? So you just apply this function and you get it. Okay, so let me do it anyway. We did this in class, right? So we have this function here. So f of x, right? So the point of interest is when x is approaching 3 from left and right. Okay, make sure you use the notation properly. So this limit is approached from smaller than 3, right? From larger than 3. Okay, from less than 3, the rule of the function will be this piece. So that's going to be x plus 3. Okay, and the next one, of course, will be the other one. If you show these work like that, I don't think anybody can take any points off you. Okay, at least I cannot. Okay, direct substitution, so 3 plus 3 equals to 6. And this case is 3 times 3 minus 3 equals to 6. Right? So what do we say about this limit? The limit is 3. And if you like to make it sweeter, right? If you'd like to make it sweeter, you can say this, right? You can say because these two limits, right? This exists, and the other one also exists, and it is equal to the same number 6. Right? You can see using the notation is very clear and concise. Very clear and concise. The next question, it comes to this, I would say, you're being quizzed on, right? You're being quizzed on. Starting from the basic, right? How did we get those things, right? Let me take the basic expression, the basic one. And that's the basic. That's the basic. I think you guys got the hang of it, right? So how do you operate on that, right? How do you operate on that? X greater than or equal to 0. So this x can easily turn into a bologna. If bologna is positive or 0, and this will all turn into bologna. You can see it's a direct, it's just a placeholder. Okay, it can be the absolute value of any quantity, right? As absolute value of any quantity, and in this case, what is being taken absolute value of? X plus 6, right? X plus 6. So this all turn into x plus 6. Omega is turning into x plus 6. Be sure you have parentheses here. You see that symbolic operation, right? And you just have to solve this inequality. Solving that inequality, what we get? Right? What do we get? X is greater than or equal to negative 6. And this piece is x is less than negative 6. You see how to operate on that? And then x, the absolute value of x plus 6 is divided into 2x plus 12. 2, and then on the top we factor it. Right? So that's how we get these two. Right? Take this piece with 2 branches and divide into 2x plus 12. Reduced, there you go, right? And point of interest is usually at when you have 2 pieces at the part that they're not. Here you can see we not using equal to negative 6. Why? Because the absolute value of x plus 6 is in the numerator, in the denominator. So when x is equals to negative 6, it's the 0 denominator. The domain, you have to be careful about domain. X is not equal to -6, right? So all of these details need to be considered, yes. Okay, so for limits, right? For limit other than -6, all direct substitution. For limit that is negative, when x is approaching -6, then you're gonna use the you're gonna use that one-sided limit. Okay, so how do we use that one-sided limit? One more time. If you like to pause the lesson and do it your own, do that. Why not? Right? And this piece, right? We already have these two pieces of function right there. So less than -6, that's this case, that's -2. And that's going to be +2, right? And what do you say about this limit? The limit, one-sided limit on both sides, both exist, but they're not the same. So then you say it does not exist. Does not exist because, geez, I think my memory is, there you go. Okay, because of what? Because these two limits are not the same. You are quoting that theorem. You're quoting the theorem. Okay, number 29, we did this in class, of course, and the same thing. But you can see the factoring technique is used here. The factoring technique is here, right? So take this piece, right? Tweaked a little bit. And this time, you would consider the domain. And what would be the domain? The domain would be, let me put this up here, okay? X cannot be 0. And X cannot be 1/2, right? If you said 2x minus 1 equals 0, then x cannot be 1/2. It's and relationship, not or, right? And then we're going to go ahead and take care of the absolute value of 2x minus 1. So this turns into 2x minus 1. 2x minus 1. 2x minus 1. I'm sure you guys got the hang of it, right? 2x minus 1. 2x minus 1. Right? Oh, wait. What am I doing here? Here. There we go. Sorry. I made a mistake. Okay. When I copy it, I copied something extra. Okay. Oh, drop this. Sorry. That omega, no more absolute value. So there's absolute value sign. There's no more absolute value sign. So on this side, no more absolute value sign. Okay. So I hope I didn't confuse anybody. And then we're going to bring these into the operation. Okay, when you bring this into operation, one of the things you can do is that you may like to first operate. I just show you a slightly different way to do it. 2x minus 1 and take an absolute value. We're going to bring x squared in later. Okay, right here. So what do I get? I already have these two pieces, right? I already have these two pieces. So I'm going to do this. There, bring this in to the picture, right? And over here, we have a 2x minus 1 divided by absolute value of 2x minus 1. And absolute value 2x minus 1 have these two cases. So the numerator is 2x minus 1, so I'm going to bring them there, right? But the absolute value, the denominator have these two branches, so I'm going to put them right in place. Right in place, right? So this is negative. I'm going to bring them right in place. And what do we get in the end? 2x minus 1 over 2x minus 1, that makes 1, right? And wait a minute, we have to have greater than 0, because it cannot be equal to 0, right? All the details need to be attended. Domain consideration, right? So next, simplify. And this is 1, and this is negative 1. Boom. And of course, you're going to bring these in, right? Because you would have solved that inequality. There we go. There we go. Nice, right? You look it back. You typically do this on scratch paper, so make sure you don't miss anything, right? You could have done this over here, right? That's even simpler. There we go. But we're still not there. We need to divide it by an x squared, right? So after we got all of these, right? We don't need the middle anymore. We divide by x squared. Divide by x squared. So we're going to bring it here. I'm going to bring it here. I'm going to bring it over here. You see that divided by x squared? Boom. We got it. We got it, right? So algebraically, you can do whichever way, you can do it whichever way you want. And then you will consider the limits. You work on which limit is, is interested in. Okay, in this question, the limit of interest is when x is approaching half from left, from right, right? And let's do it. Let's do it. And if you have a picture, it's great. If you don't have a picture, no big deal. No big deal. Okay, because you already have the piecewise function there. So I'm going to bring it here, okay, pretending we don't see the picture, right? Because sometimes the picture is hard to come by during the exam. The picture, if the picture is necessary, I will give it to you. And sometimes if the picture is not necessary, I may not give it to you. You have to work with this piece. Okay, so less than half from left, from right. So let's look at them, right? From right. Okay, so what do we get on this piece? Here, smaller than half. And that's going to be this limit from smaller than half. I'm going to use this piece, right? That function will be used, right? That function will be used. Larger, boom. The next one, larger, there we go. Okay, domain, 1 over x squared. Half is in the domain of 1 over x squared, or negative 1 over x squared. Right? And then what do we do? Then what do we do? Denominator will not be 0 when we are considering. So considering this function, no issues of 0 denominator. So it's going to be a direct substitution. Direct substitution. Negative 1 over x squared, and this x is going to be half. 1 over 2 squared. What do we get in the end? Negative 1 over a quarter. Okay, reduce that fraction, we get -4. And the next one, right, is direct substitution. Once again, is 1/2 squared, right? Direct substitution. And it's going to be a +4. Limit from the left and limit from the right are not the same. So what do we say about the limit? Right? So this limit is not the same as the limit from the other side. Limit from the right is not the same as limit from left. So this limit as x approaching half does not exist. Okay? So in summary, what have we seen? What have we seen? We have seen that at the beginning, when we talk about those cases, right, when limit does not exist, seem that C happens quite often. A and B could happen too, okay? By the way, A and B could happen too, okay? But in our homework, C happens more often. Why? Because it involves more work. So it allows your teacher to assess you more. Okay. I think that's all for this. No, wait a minute. Let me just do 44, 45, 46, these 3 questions. 44, we did it in class. I don't think it's necessary for us to do it again. 45 and 46. Let's quickly just get them done. Okay. So 45, if you want me to do 44, if you have issues with 44, let me know. Okay. I don't want to make this video too long. That's why, I kind of want to jump to, so this is, it's in your worksheet. Okay, so here we go. Okay, because this limit 45, right, when x is approaching 0 from smaller than 0, so the absolute value of a negative number is its opposite. Okay, so for this function, right, of course we have 2 branches, but if you only consider the limit, right, sometimes the work you don't have to do so much work as if you work with x approaching 0 from smaller than 0, right? So if you consider just that, you don't need to even to make the branch. Okay, so let me put that away. Okay, so that's our 45. That's our 45. Domain, of course, x is not equal to 0. Everybody knows that. If you just consider this limit, you don't need to make the branches. You don't need to make the branches. What you can do is that x is approaching 0 from smaller than 0. So what you know about it is x is going to be negative. And the absolute value of a negative number is its opposite. You see? I am using that. I'm using this piece. I am really using this piece. The powerful statement here equals to. Okay. I can't emphasize enough that you get that narrative. The absolute value of a non-negative number is the same as the number. The absolute value of a negative number is its opposite. So here I'm merely just using this piece. because I know x is approaching 0 from smaller than 0. So I don't need to make those branches. Okay, if you want, you can go it, but it's work you don't have to do. Okay, and then what? Well, next step is combine like terms, right? Minus 1 over negative x, that's going to be plus 1 over x. And that's going to be 2 over x. There. So x is approaching 0 from smaller than 0. So this is going to be what? This is going to be negative infinity. Negative infinity. You're finished. You're finished. Right? And on the worksheet, of course, I showed you how to do the branches. They're even pictures. But really, these are extra questions. These are extra questions. Okay, these are extra questions. Okay, there's another question, 32 here. You can work it. Number 46 right here, this one. Okay. So I'm going to insert this question right here. This is additional because I did it in class at the time of preparing this worksheet, and I didn't think of including this part since we are here. So let's just do it. X approaching 0 from larger than 0. And so what do we have here? We have 1 over x minus 1 over the absolute value of x. There. Okay, once again, we don't have to do the branch. We don't have to do the branch because we know x is positive. If x is positive, right, I'm going to apply this piece, which is very useful. You don't have to explicitly write, but I just want to show you I'm using this piece. Okay, the absolute value of positive number. How do I know absolute value? I'm taking absolute value positive number because x approaching 0 from greater than 0. So this is same. So I'm using this branch. And 1 over x minus 1 over x. What do I get? Well, you know that. That's going to be 0. Right? And that limit is 0. Done. No more no branches needed. Okay. So we got 32 and all these other questions, and I'm going to leave them for you because this has been long enough. Thank you for watching. I just hope that these will be helpful for you. Thank you for watching.